Okay, this is the first problem on our review for the Module 1 assessment. And number 1 is determine if each sequence is arithmetic, geometric, or neither. Then find the missing terms. Alright, so remember, if a sequence is arithmetic, we have a common difference. If a sequence is geometric, we have a common ratio. And if a sequence does not have a common difference or a common ratio, then it is neither over here. So let's take a look at this first sequence right here. And let's see if we see the pattern. 3, -6, +12, -24. Now, as soon as I see terms oscillating from positive to negative to positive to negative, I'm thinking I might have a common ratio. And do you agree that if I take this 3 and I multiply it by -2, I'd get -6? And then -6 times -2 would give me a +12. So I am conjecturing right here that I have a common ratio, and that would be -2. And let's keep going here. 12 times that -2 would be -24. -24 times -2 would be +48. 48 times -2 would be a -96. And if you need your calculator, get your calculator out. Be careful. Get these problems all right. And -96 times -2, well, negative times a negative is a positive, and that would be what, 180, 192. And there's our first part, part A. All right, so expand your sequence, and again, because we have a common ratio right here, we know it is geometric. The next one, 2, 5, 8, 11. Well, that's pretty easy to see. Don't we have a common difference of 3 every time? And that implies 11 plus 3, 14, plus 3, 17, plus 3, 20. And again, when I have a common difference, I am arithmetic. Now this one, -1, -3, -9, -27. Well, they're all negative. And -1 to -3 to -9, it still looks like I have a common ratio though to me. See if you agree. If I take this -1 and I multiply it by 3, -1 times 3 is -3. -3 times 3 is -9. -9 times 3 is -27. So common ratio is 3. And let's keep going. -27 times 3 is -81. Now, I'm not going to take a chance, so I'm going to get out my calculator. I hope you do the same right here. All right, so I'm going to go -81 times 3, -81 times 3. I hope you can find the negative button on your calculator. And I get -243. And then if I take that number and I multiply by +3 again, my common ratio, I get -729. So again, when they get a little rough, just break out your calculator. It's okay. All right. So this one, C again, has a common ratio. All right. And if I have a common ratio, I am geometric. One more. 2, 3, 5, and 8. Well, I'm not adding the same number. And you know what? It doesn't look like I'm multiplying by the same number. All right. So again, I could check this like this. If I go 3 divided by 2, I don't get the same number as if I go 5 divided by 3. So this does not have a common difference or a common ratio. All right. So it's going to be neither over here. But let's see if we can still see a pattern. This is going to be fun. All right. So do you all agree that it looks like I added 1? And then to get from 3 to 5, I added 2. And then from 5 to 8, I added 3. So there's a pattern right there. Let's try to continue this. So 8, I'll add 4 to get 12. And the 12, I will add now 5 to get 17. And for the 17, I'm going to add 6 to get 23. Oh, I like this. And for the 23, I'm going to add 7 to get my last term in this sequence of 30. All right. So because though there is not a common ratio or a common difference, this sequence of numbers is neither arithmetic nor geometric. It's a neither. And there's our first problem in the review. I hope you enjoyed that. Okay, this looks like a great set of problems right here. Let's take a look at number 2. The sequence below is geometric. Well, that would imply I must have a common ratio. All right, and then what will the next 2 numbers in the sequence be? All right, well, they only gave me 2 terms, but they told me it's geometric, so my first term is 3/5, my second term is 3. What would I multiply 3/5 by to get 3? Because I know I have to have a common ratio. Well, isn't 3/5 times 5 3? Yeah, because if you did that multiplication, the 5s would just cancel and leave the 3. So the common ratio is 5. And now I need to use that to select the correct answer, A, B, C, or D. So let's get our next term, 3 times 5. 15. 15 times 5. That would be what? 15 times 5 would be 5 times 10. That's a 75. So the answer is C. All right. The next one. The sequence below is an arithmetic. Well, if I'm arithmetic, I don't have a common ratio. I have a common difference. And what am I adding to this negative 18 to get to 0? Wouldn't that just be an 18? So the common difference has to be 18. Now, let's just go to our next term. 0 plus 18 would give me 18. And 18 plus 18 would give me 36. So the next 2 terms would be 18, 36. And isn't that an A right there? Oh, I like this. Now, oh, look, they skipped. Interesting. So find this, if the sequence below is arithmetic, determine the missing numbers and the common difference. So they're saying arithmetic, so I have a common difference. All right. Okay, now in 2 steps, I went from 5 to 17. All right, so let me see. What could I add to 5 to get a number that if I add that number to this number, I get 17? Well, what's the distance from 5 to 17? That'd be 12, wouldn't it? So doesn't that mean to get halfway there, I would just add 6? So I think there's a common difference of 6. Let's see if this works. 5 plus 6 is 11. 11 plus 6 is 17. 17 plus 6 is 23. And 23 plus 6 is 29. Nice, that's it. So number 5, if the sequence below is geometric, determine the missing numbers and the common ratio. So I know if I'm geometric, I have a common ratio. All right, so now when I do my 2 steps, I'm multiplying. All right, so what do I multiply 4 by to get to 16? To do 2 steps, wouldn't I have to multiply by 4? So doesn't that imply to get to 1 step, I'd only multiply by 2? So I think the common ratio is a 2. Now, let's just check and see if this works. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. That's a great set of problems right there. I hope you enjoyed them, and I hope you understand them. All right, I'll be back soon. Okay, so number 6, they give us the linear equation in point-slope form, f of x equals 2 times the quantity x minus 1 plus 3. And then they are asking us to find the values of f of 1, f of 2, and f of 3. So how do we find f of 1? Well, we use our explicit function right here, and we're just going to do direct substitution. So we're finding f of what x value? F of 1. And that implies we're going to take this expression right here and we're going to substitute a 1 for this x. So I have the 2, and then I have parenthesis, and if this x is 1, 1 minus 1 is 0. So that's 2 times 0 plus the 3. And what is 2 times 0 plus 3? 3. All right, let's do the other two now. So f of 2 would be, well, now my x is a 2. 2 minus 1 is 1. So let's put a 1 right there, direct substitution. And then 2 times 1 is 2 plus 3 more, 5. And now the x is a 3. So we're going to go, this x is a 3, so 2 times 3 minus 1 is 2. And 2 times 2 is 4, plus 3 more is 7. F of 3 is 7. Direct substitution. Okay, next slide. Number 7 and number 8. So, number 7, which table of values fits the function rule f of 1 equals 2, and then f of n equals f of n minus 1 plus 2? All right, this is a recursive formula, and I've been telling you that a recursive formula is nothing more than shorthand for a table. And they have given us 4 tables down here. Which one's the correct? Now remember, your initial condition in function notation, f of 1 equals 2, well, that's giving me the point when x equals 1, y equals 2. So I just look at the table. 1, 2, that one works. 1, 1, no. 1, 2, this one could work, and that one does not. Now, the recursion equation, this part, f of n equals f of n minus 1 plus 2. Do you see this plus 2 right here? That's my type of change. So the term I am looking for is the previous term plus 2. So let's look at our f of n's here and over here and see where I'm adding 2. Well, I added 2 there, but I did not add 2. Let's hope it happens here. 2 plus 2 is 4, and 4 plus 2 is 6. The common difference is 2. We added 2 there, and we added 2 there. That tells me that this table is correct. And I'm sorry, but I covered up my answer of C, so I'm going to write it below. The answer to number 7 is C. Now, number 8. Which table of values fits the function rule for f of x equals 6 times 3 to the x minus 1? Okay, so this is an exponential function where if we had a table because of this x minus 1, that means the first x in my table is 1. So I know that my first x has to be 1 and I have to be exponential. Okay, well, man, the first x is 1 in all of them, so that doesn't help me there. But now I know it's exponential, so let's go to the general form of an exponential so we can see the parts here. So the general form of an exponential when my first x in my table is a 1 is a times b to the x minus 1. So that tells me that my a is 6. Right there. And that is always my first output or my f of 1. So I know f of 1 is 6. 1, 2, that does not work. 1, 6, that could be a possibility. That could be a possibility. That one doesn't work. So I already know the answer is B or C. And now if I understand the base, which is the same thing as the common ratio, the common ratio is that base right there, which is 3. So that means I am multiplying by 3. 6 times 3 is not 12, so that's out. 6 times 3 is 18, and 18 times 3 is 54. So again, my answer is C. Okay, this slide, or problems 9 through 13, this could be my favorite slide on this whole presentation right here. I mean, this is almost all of Module 1 right here on one slide in PowerPoint. Let's look at the directions. match each item on the left. So on the left, I either have an explicit formula or a recursive formula with a different representation from the same sequence on the right. So we have here either a sequence or a table or a graph. So we're going to match the function, whether or not it is explicit or recursive, with the sequence, the table, or the graph, whatever is given. So let's take a look at number 9. F of x equals negative 4x plus 1. Now, isn't that our old y equals mx plus b? So with that, I know, okay, this x right here, well, if x is 0 and I start with an x equals 0, if I'm going to use slope-intercept, and I know it's a line, I know this is linear, so I'm going to look at my models over here on the right, and I want to know when I have an initial x value of 0 and I have something that is linear right here. All right, well, let's think about that. mx plus b again. Well, if x is 0, isn't negative 4 times 0 plus 1 going to give me a 1? So look at this table right here. Okay, f of 0 has to equal, one more time, negative 4 times 0 is 0 plus 1 is 1. And that is represented right there. Do I see it anywhere else? I don't think I do. And the common difference is my slope, and that's a 1, or excuse me, a negative 4 right there. So that means that my outputs are going to have a common difference of negative 4. Or if I'm looking at a line, that line has to have a slope of negative 4. Well, let's look at the f of x's in this table right here. 1 minus 4 is negative 3. Negative 3 minus 4 is negative 7. Negative 7 minus 4 is negative 11. And negative 11 minus 4 is negative 15. This table is the table for this function, f of x equals negative 4x plus 1. So the answer to number 9 is B. Now, on number 10, they give me a recursive formula. And this might actually be way easier to work with because f of 1 equals 6. Doesn't that mean my first term has to be a 6 in my model over here on the right? Oh, I crossed out the b too because I'm done with it. I'm not going to use that again. So f of 1 equals 6. Well, look at this sequence right here. The first term is 6, so that's a possibility. And then look at your recursion equation right here. Do you see the plus 3? Doesn't this mean the term I'm looking for will always be the previous term plus 3? So this 6, if I add 3, do I get 9? Because I have a common difference of 3 right there. Yes. And if I add 3 to 9, do I get 12? Yes. If I add 3 to 12, do I get 15? So this recursive formula gives me a sequence. The first term is 6, and then to get every next term I simply add 3, 6, 9, 12, and 15, and so on. So the answer to 10 is C. Now, another recursive formula right here. I love these. My first term is 2. Oh, cross out that C, we're done. So f of 1 equals 2. Well, look at the table down here. When x equals 1, does f of 1 equal 2? That table could be my solution, but we better check this. The recursion equation. The term I am looking for is always the previous term times 4. Times 4 is the key, so I have a common ratio here of 4. Well, look here. The 2. If I multiply 2 by 4, do I get 8? Yes. How about 8 times 4? 32. 32 times 4? 128. If you're not sure, check that on your calculator. And if you go 128 times 4 on your calculator, I promise you're going to get 512. So the answer to number 11 is E. Cross out that E right there. Okay, number 12. Okay, this is exponential. This is f of x equals 3 times 2 to the x minus 1. Now, because I have an x minus 1, that means that my first x is going to be a 1, and my output when x equals 1 has to be this 3 right here. That tells me all of that right there. I know I'm going to begin with an x equals 1 and I'm exponential. And because of my general form of an exponential, which is f of x equals a times b to the x minus 1, and that's if my first x is a 1, well, my a has to be 3. So my first output is 3. So I'm looking for a first output of 3. Look at the sequence at the top. There it is. Now, this 2 is my common ratio or my base. So I have a common ratio of 2 right here. R equals 2. So let's check it. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. This sequence represents this explicit function f of x equals 3 times 2 to the x minus 1 power. Just for a little extra, let's play around a little bit. Let's see. Let's look at the third term. First term, second. The third term is 12. That means my x is 12. All right? So let's think about that a second. 2 to the 11 times 3. Let's go here. So the third term, okay, x is 3. Well, 3 minus 1 is a 2, and 2 to the second power is 2 times 2 are 4. 4 times 3 is 12. That's how that works. All right, so it looks like the answer to number 12 is that A. Cross it out. So we already know the answer to number 13 has got to be D, but let's double check it, because if this works, I almost know I have to have everything else right. And I'd like to get 100% on this test. So f of 1 is 6. So if I look at this graph, is this point right here x equals 1 and f of x is 6? Well, there's 1, and hard to see. 1, 2, 3, 4, 5, 6. Yes. So that worked. And now f of x, the term I'm looking for, is the previous term minus 2. Well, that's a common difference of negative 2 right there. And that's a slope of a linear equation. All right? So I want to know, to get from this point to this point, am I always going to do a slope of negative 2? So I'm going to do a slope triangle right there. And did I drop 2? I'm rising negative 2. And did I run 1? Yeah, I'm running 1. And is that going to work every time? Drop 2, run 1. Drop 2, run 1. Why, yes, it does. So f of 1 equals 6 represents my first point in the scatter plot, and f of x equals f of x minus 1 minus 2 will give me the y coordinate of every other point. So this is 2, 4, this is 3, 2, and this is 4, 0 right there. So the answer to 13 has to be a D. Nice. This is pretty. Okay. Number 14. List the functions from numbers 9 through 13 that are in recursive form. And then list the functions from numbers 9 through 13 that are in explicit form. So all they're asking us to do is know the difference between a recursive formula and an explicit formula. So I put a little note here to myself. For recursive, I am looking for an initial condition in function notation, f of some number equals another number, and then my recursion equation will be f of x equals f of x minus 1, and then I'm either going to multiply, add, or subtract to my f of x minus 1 right there. So that's recursive. Now explicit, here's one example, f of x equals mx plus b. That's slope-intercept. And you guys know you have like f of x equals ab to the x for exponential. You also have point slope, f of x equals m times the quantity x minus 1 plus b. Or you have another exponential where your first x is a 1. F of x equals a times b to the x minus 1. So know the difference between a recursive and an explicit. So let's go take a look. Okay. We're looking first for what? I forget. What did they ask for first? They asked for recursive. So let's find our recursive here. Well, this is explicit. Number 10 is recursive. Number 11 is recursive. And number 13 is recursive. So the answer to number 14 is 10, 11, and 13 are all recursive formulas. Now, what are the explicits then? Well, let's double check. 9 is explicit. This is slope-intercept of a linear function. And 12 is explicit. This is the exponential function when my first x value is a 1 right there. So it's just 9 and 12 are explicit. There you go. Now, let's look at number 15. Use the graph at the right to write the recursive function for the sequence. All right, well, the key is, what are the coordinates of this first point right here? Because again, recursive, you know what I'm looking for. Initial condition, f of blank is blank, and then the recursion equation, f of x equals the previous output, f of x minus 1, and then am I adding, subtracting, or multiplying? Well, let's start with our initial condition, that point right there. Do you agree that the x is 0 and f of 0 is 9? So f of my x value, f of 0, is my y value of that point, 9. Okay, now this looks linear, and since I'm going down, that's linear decay, I'm going to subtract from the previous term every time. And you can think of this as just the y value or a slope here. Well, let's think of it as slope like we typically do with a common difference. Okay, do you agree that we are dropping 1, 2, 3, and we're running 1? I think that needs to be a minus 3 right there. Let's see if I showed you a little more right there. Yeah, I just did a slope triangle right here, and my rise is -3, and my run is 1. So this slope, -3 over 1, is the same thing as my common difference, which would be -3, which means to get the next term, I'm going to take the previous term and subtract 3 every time. And I double check that works every time, so there's a -3 right there. Now, write the explicit function for the sequence. Okay, now explicit. Well, I have a y-intercept and I have a slope. So why don't we just go slope-intercept form of a line? So f of x equals, and we know this is going to be an m times x plus b, where m is my slope. Well, you see the slope right here. I'm rising -3 and I'm running 1. And the slope is the same as the common difference, which I see above. So I know this slope has to be -3. And the y-intercept I can clearly see is that 9 right there. So my b is 9 plus 9. There's my explicit formula right there. Now, find the 100th term of this sequence. So what is f of 100? Well, I'm not going to use a recursive to do that, but I could sure use the explicit. So f of 100 equals -3 times, well, x, my x is 100, -3 times 100 plus 9. Now let's simplify that. -3 times 100 is -300 plus 9, -291. And that's number 15. Number 16. Use the pattern of figure 1, figure 2, and figure 3. We could have said use the diagram to 16a. Create a table for this pattern. Okay, easy. My inputs would be 1, 2, 3, and my outputs would be the number of squares I see in each diagram. So let's start with our first input, figure 1, x equals 1. And how many dots do you see? 5. In figure 2, how many dots do we see? 9. And in figure 3, how many dots do we see? Well, I'm going to count these like this. 3, 6, 9, 12, and that center dot would be 13. 13. There we go. There's our table. Now, write the recursive function for the model, and they've set you up right here. All we need to do is fill in these blanks. The first term in function notation, like we say every time, is just that first point when x equals 1, f of 1 is 5 in function notation. So what did we say? F of my x value, f of 1, is my f of x value, which is a 5. And there's my initial condition in function notation. And now the function rule, which we call the recursion equation, f of x equals f of x minus 1. And now how are my f of x changing right here? Do I have a common difference or a common ratio? It looks like I have a common difference. What am I adding every time? Well, 5 plus 4 is 9. 9 plus 4 is 13. We have a common difference of 4. So to get the term I'm looking for in f of x, I'm just going to take the previous time and every time. 5 plus 4 is 9. 9 plus 4 is 13. We're adding 4. And there's number 16. Okay, here's the last problem on our review, number 17. And of course, this is a context problem, a little story problem for us. There are 8 students in the math club at Black Hills High School. All right, and every week 3 more students join the club because it is really popular. So 17a, write the recursive function for this situation. And I don't have a lot of room here. I can put them down here. Write the recursive function. So doesn't a recursive function have 2 parts? See here I have recursive and explicit. And the recursive again has my initial condition in function notation. And then our recursion equation, f of x equals f of x minus b, plus or minus some number or times some number. And in the last slide, they called this the, what do they call it? It was recursion equation. I think they called it a function rule. Kind of cool. All right, so let's see. There are 8 students in the math club. That means when this club started, or maybe today, so I'm going to call the input 0. How many students are in the club? 8. All right. Now, that's my initial condition in function notation. And then we have our recursion equation, or our function rule, if you like. F of x equals f of x minus 1. So the term I'm looking for is the previous output, and then what are we doing every time? So like every week 3 more students join the club. That means in 1 week we won't have 8, we will have 11. What did we do to this 8? We added 11. So this up here tells me I have a common difference of 3. So all I'm going to do is add 3 every time. There's my recursive. Now, explicit. Well, f of 0 equals 8, and f of x equals f of x minus 1 plus 3. Well, when I have a common difference, I have a slope. This is linear. And my first x is 0, so I get to use f of x equals mx plus b, a slope-intercept of a line. Man, that's big right there. So let's see what we know. F of x equals, so aren't we adding 3 students every week? And don't we see that in the problem? And I see it in my recursion equation with this plus 3. So I'm going to say my slope is 3. And then b is my y-intercept, or f of 0. And f of 0 is 8. So this is going to be f of x has to equal 3x plus 8. This is explicit. This is recursive. And we are done with the review. Now I want to give you a little note to finish up. Know the difference between an arithmetic and a geometric model. Like if this had been geometric, instead of plus 3, we would have a times 3 right there. All right? Okay? And be able to give an example of each. You guys are great at that. You're going to do great on this test. And if you have more questions, you make sure you get a hold of me. Thank you. Have a great day.